Okay, so Eg4, another contextualized question. So a cold liquid at temperature theta degrees centigrade, where theta is less than 20, is standing in a warm room. Temperature of the liquid obeys the differential equation d theta dt, so there's my rate of change, how the temperature changes with respect to time, equals 2 bracket 20 minus theta, where t is measured in seconds. So the first thing, find the general solution of this differential equation. So it's a general solution, so it will include a constant. It's a solution to a differential equation. I only know one way of doing that, which is separating the variables. So if I bring my theta across to the left hand side, I end up with that, and on the right hand side I end up with 2 dt. Now this is an integral that you could recognize from the reverse chain rule, but in case you don't, I'm going to use the substitution method in order to integrate that side. So I'm going to do that first. So I'm not sure about integrating 1 over 20 minus theta, but if that was 1 over u, I know that the integral will be ln u, natural log of u, and because the differential of this turns out to be minus 1, it is something that I'm able to do and replace the d theta by u. So if I let u equal 20 minus theta, and if I differentiate that with respect to theta, I get negative 1. So rearranging that, then I want d theta now in terms of du, so that will lead to d theta being minus 1 times du. So this then becomes is the same as the integral of 1 over u, and instead of the d theta I'm going to have minus du. So I'm going to integrate basically minus 1 over u du, which will be minus ln of u. And once I've done my integration, I can then put the substitution back in, which gives me that. I have to put the modulus sign in, symbols in, to show that that has to be positive. But because in the context of the question, theta is less than 20, that will always be positive. So that's fine to write as minus natural log of 20 minus theta in brackets. Going back to my original integral, so I've labelled that as 1, so I've integrated this side, so I've got my minus natural log 20 minus theta, which is the integral of that, equals, integrating this, 2t plus a constant. I need to have a general solution, so what I need to have is theta equals. So I've got more work to do here. If I deal with a negative first of all, so basically multiplying throughout by minus 1, that becomes a minus 2t, and this constant, I'm just going to absorb the minus 1 into it, because we don't know the value of that yet, so we can just leave that as plus c. Now to get into that function, I need to do the opposite of the natural log, which is exponential. If I exponential that side, the e and ln undo each other, and I'm left with that. This side becomes e to the minus 2t plus c. Now, example 1, in example 1 I talked about how we can then combine that to get a different form of the constant, because this is going to be the same as e to the minus 2t times e to the c, which we're going to call a. So we get 20 minus theta equals a times e to the minus 2t, because e to a constant is another constant. And I want theta equals, so rearranging this finally, I'm going to get theta, so I'm going to make that positive, is 20, and then bringing that across, minus a e to the minus 2t. So that is my general solution. So this work here, okay, if you're happy from the work you've done in integrating in pure, if you're happy spotting that that's going to be the natural log of that multiplied by -1, because that's what you get from differentiating that, which is the reverse chain rule, that's fine. You can just write that straight down. Part B, find the particular solution for which theta equals 5 when t equals 0. So when t equals 0, theta equals 5. So 5 equals 20 minus a e to the 0. Well, anything to the 0 equals 1. So that would be 5 equals 20 minus a. So a is going to be 15. So therefore, particular solution will be theta equals 20 minus 15 e to the minus 2t. So that's your particular solution. And then part C, in this case, so that means we can use that particular solution. How long does the liquid take to reach a temperature of 18 degrees C? So if I rewrite my particular solution, so I don't have to keep flicking back. Okay, so that's the equation we're working with, and I want to find out what T is for theta equals 18. Okay, so 18 equals 20 minus 15 e to the minus 2t. 15 e to the minus 2t is going to be 20 minus 18, which is 2. E to the minus 2t will be 2 over 15. Now I need to get into that function, so I've got to undo the e, which is the ln. So when I take ln, I get minus 2t on that side, equals ln of 2 over 15. So t will be minus half, taking the minus 2 over, ln of 2 over 15. I'll get my calculator on now. So let's put this in exactly as we see it. So let's speed it up a bit. So I've got 0.5 natural log fraction, I know it's minus 0.5. Minus 0.5 natural log fraction 2 over 15, close the bracket, 1.01 seconds. So there we are, that's a nice contextualized example with a slightly trickier integration, but one that certainly you should be comfortable with from your Unit 3 integration work. Substitution is a sort of last resort if you don't spot it.